agents are already writing code, reviewing ads, and making decisions. But who is watching them? Today's guest has spent her entire career at the intersection of data and automation, from fraud detection at Capital One to data infrastructure at Block to Gen AI at Reddit. In this episode, we get into real talk. How do you scale AI safely? What is contract first development? And why your agentic AI system might be one API key away from a $20,000 disaster. Let's get into it. Walk us through your Devon, Block, and now Reddit.
Yeah.
What are you looking for when you are making those changes?
I have been building, when I first was in college, I studied statistics, but then I found the bottleneck is not really this whole automation itself, is the infrastructure that we need to build on. Like, for example, we are trying to gather some data, and it was not that easy. So you have to talk to so many teams. You have to figure out, how their data looks like. You don't know the quality, even though Capital One is already fairly enterprise. You go to their data catalog portal, you see a lot of data, but you just don't know. So at the time, I thought, okay, this space is very fun, but then without the infrastructure. If you remember the project we worked together, we focused so much on the infrastructure. We had so many different data platforms. It was the same problem. And we go everywhere to find the data, everywhere data is different. We work together to consolidate all these different platforms. So then it's easier to use these data. In a way, you can say, it will work, but it won't work at scale. Like the way if the system is very fragmented, it's very hard to whether you're building a model, you're building a pipeline, it's possible, but you're just iterating at much slower rate because you have to figure out all the little details from different platforms. Anyway, talking very long, then move on to Reddit. And then we have, at the time at Reddit, we have this new thing called large language model, so popular, everyone knows about it. ChatGPT, Anthropic, Gemini, everyone's making it. And I truly also believe it's such a great technical invention or iteration of technology. Like the way I think about it, when we build data pipeline, the enrichment was a lot about making calculations, writing this attribute divided by that attribute equals something, and that's the signal for, say, this person visits 6 times over the past 3 days. That's a signal for how often, how interested this person is. But with Gen AI, we can see, okay, he has been browsing this category of product, and we can automatically use Gen AI to say, hey, based on this history, can you tell us which is he more interested in this list of very generic, he has browsed, I don't know, this person has brought something about refrigerator, something about bikes, something about, let's say, children's clothes, for example. We don't know, it's very generically broad range of different contents. And with Gen AI, unlocks, like, because for us to develop the math to figure it out, what is this person actually doing? So hard. But with Gen AI, we're able to label generic content a lot more easier. And that is what I do at Reddit most of the time, is to use Gen AI as a way to do data enrichment and to basically this unlock a whole new field of data enrichment we weren't able to do manually. Give you one example, somebody submit an ad, it's legit. What if it's selling some fraud product? And used to be, people has to review it one by one. We can use Gen AI to review almost 90% of the submission. So much more data enrichment and labeling, in my opinion. That's like, anyway, long story short, I have been working on data for the eternity of my career, and just different parts of it, different techniques, depends on where I see the bottleneck is. It just driven me to work on those interesting bottleneck. But yeah, that's pretty much it.
You have seen the entire life cycle of data from the statistics standpoint to the point it gets created to the point now with the AI models.
So right now, a lot of data processing that we do, let's take a Snowflake, BigQuery, what's the other? Databricks. for example, these are like the go-to enterprise data processing tools we have. So many things you can do with the large language model. It's an important part of data enrichment. The scaling, like let's say you make a dramatic number, 20 million document, but if you just say, okay, 20 million documents, I want to label every single document, what they are, go to ChatGPT. So Databricks invented because you can scale compute much more efficiently, much more cheaper because the memory and compute are separated. But if you think about we're trying to scale the Gen AI enrichment, data enrichment, well, there is no great framework at the moment. Like, how would you scale? Do you want to enrich more and more documents? You want to label more and more documents, more and more images and stuff? But you cannot yet at this moment, just like Databricks, just separate the compute and memory. You have to bring the compute and memory, everything together to be able to make that inference. And it's usually like, it's not, how do I put it? It's not, you don't necessarily need to distribute it. Like the processing layer, it's not hard. It's about being able to have enough GPU, being able to have enough hardware match your workload to be able to make inference. So the scaling is a little different. But anyway, like analytics or data processing versus the new way where we add LLM to the mix. Like we want to do data processing with LLM. Your scaling your infrastructure is going to be a little bit different of how you optimize your costs and scale and the type of workload.
Yeah, I particularly noticed the use case you are describing. At Toyota, woven by Toyota, we were building the voice assistant for Lexus. And
Yes,
that's where we were using also frontier models
yes,
because with the network connects can be very choppy. And if
y-
the model is too big, it takes while for all those processing compute needs to go back and come. And with the network lag, it's just not possible. And we can't run large models in the car. It will heat
yes,
up. We need extensive GPU power to run it, and car will pretty
yes,
much burn. So with all those safety liability issues, we'll
yes,
run smaller models or frontier
yes,
models. So
yes,
how do you decide trade-off between which model is the right model to use and
yes.
how to go about it?
So you're not gonna burn your money, right? Let's say today you're cooking for one people, you're using a smaller pot. Tomorrow you're cooking for your entire family, you're using a bigger pot. Like it's the same analogy, you're making an inference on a relatively simple task. You use a small model. Why do you use a frontier model and basically, push all the limits, all the hardware limit, GPU limit, networking, everything, all the limit you could possibly have? You just use the right model for the right task. So in my opinion, to solve this type of problem is to first, we were in a bit because like us using the frontier models, we're in a bit of habit. Like, let me just throw all my problem at the frontier model. It's pretty good. It will solve my problem. But in reality, when you're trying to scale this, you're talking about, scaling software, scale your processing image on a very high rate. You're processing the entire history of all your documents, this type of scale. It might be very helpful to basically break down the task, what you're trying to make a prediction on, based on basically, if you say this task originally, I need to make 10 prediction together. You break it down, you say, okay, make one prediction like this, make another prediction. So you make a lot of smaller tasks. In my opinion, once your task is smaller, your prediction can be much, much more reliable without a super powerful model. So first, you got to segment your task, and different open source model is good at different type of tasks. So right now, there is some bench for code specifically. There's a lot of small language model that is very good at specific type of code generate tasks, generating syntax verification, things like that. So there's a lot of specialty small language model that can do that without burning through your GPU budget. So that is one way you can tackle that. In my opinion, this thing doesn't exist, but I hope I can make it exist. In my opinion, American models tell you, did you structure your problem good enough? If you structure your problem good enough, what are the models that are very performant, that will be very performant based on your task types? That makes sense? So this thing doesn't really exist today, but this type of workload, then we will have to eventually have some sort of framework to basically say, you are trying to make this inference. This is how you break down your problems. And this is all the model that I will benchmark against this type of problem. And over time, with this data available, we'll be able to much quickly to say, this is how you break down a problem into a smaller problem. And for this type of problem task, these are the model that's better for you, and you can choose and decide, depending on your infrastructure provider, depending on your GPU, you can choose and decide what kind of smaller model will perform the best on the smaller task, specific task you have. That makes sense.
It does. And I like how you describe that based on your task, based on your need, finding the right model and benchmarking to that category.
It's all kind of benchmarking against like the academia or experimentation task, like Berkeley, Stanford, like a lot of college research institution, they have like an open benchmarking. That's why you hear the headline like, Mythos is as smart as, I don't know, PhD level student, things like it's against certain benchmark. So those type of benchmarking exist, and you can always just go a dashboard, I believe, out there. You can search and find, how are all the frontier model go against. But just to be fair, we're not doing PhD work every single day. Our work sometimes is unfortunately kind of simpler than what PhD needs to do. So I think that's like where it's missing, like typically because the frontier you the capability. This is the security flaws we can catch. This is the type of like a crazy reasoning we can do with our models. Interesting, these benchmark only tells you about the performance, not the cost. So well, like I'm not really seeing even like a one benchmarking about this frontier model is caring about the cost, academia data set, research data set, and you will be able to see, ChatGPT is better in say, this is a false example, but for example, like for coding, there's a dedicated data set. For say math, there's a dedicated data set. There's a lot of these open curated data set out there. I believe Berkeley has like a dashboard or something. You can look it up. But anyway, like you can look at all these up. I think the missing point is more like the things we do every day does not require a PhD in mathematics. We do editing, which I just bases out. You can just detect very easily the voice trend on the video, and you just cross check with the video image. Like that is not hard. This is maybe I wouldn't say you don't need PhD to do that. Maybe you need a person with certain skill to be able to detect it, but you certainly don't need a mathematical PhD to do that for you.
Absolutely. And you also wrote about it on contract. Do you
Yeah.
want to tell our users about it? Like, what is contract first development and what inspired you to write about it more?
Yeah, I believe you know a lot of software engineer. Whenever you have a technical problem, say, I want to build an app, you go to your software engineer friend, say, hey, look at the app I built. Is it cool? Look at their app, I say, oh, that's very cool. How does it work? And then because of these cloud code, cursor, and all that, all these code generation. My friend showed me a lot of apps, and I said, okay, show me the code. How does it work? How does the backend work? How do you add, this type of feature? Nobody knows. Nobody think through an app. So the way that software engineer approach how to build an app, and the way that you as a user, you're also technical, but you as more like an end user approach to build an app is slightly different. Like when we say, hey, we want to build a super simple app. Let's say we want to build a hotel booking app, which is a classic interview question for so many companies. Let's say we want to build that app. And it can be any app really, like any scheduling use case. We want to build such an app, and that the user, like as an end user, when you think about this app, what do you think about? You think, I need to search, so there needs to be a box, and I need to list all the hotels, so I'm gonna get a list of hotels I wanna. And then inside it, I need to list all the rooms, so I give a list of the room. You kind of, when you build, you kind of go from, oh, this is what I see, so I'm gonna build that thing out. Once I build the little, oh, why is the hotel not updating? I go to like a step by step, trying to think through. So I need to a database to track hotels. Wait, what if there are, there are two person trying to book the same room, things like that. You try to think backwards to your problem, not from the source of the problem to the end product, if that makes sense. This is not the fault to fool people. More like when you're trying to mimic something, how do we build the first airplane? We look at the bird. We try to do a object that's really similar to a bird and hope that it will fly. But then how do we eventually do Bless you. How do we eventually build an airplane? We figure out the physics that if the air is traveling faster underneath and the air traveling above is slower, it will normally push an airplane up. And I think through this problem, and you're building an airplane by mimicking a bird eventually won't work. It just costs you a ton of time and iteration. And plus, those are all in conversations versus the way that software engineer trying to think through and after we got, okay, so in order to show hotels, we need a database. In order to filter, then we need an API. We need this, and that API. By the way, if you add a logging, then we need a new set of third-party, identity management providers, things like that. So the way we approach the app, or really trying to build a productionized app, is like a very, very different. So I was trying the process. I'm trying to think, okay, how can I help my friend think through a problem like this without telling them you're doing something wrong, but giving you a framework to say, if you want to build an app that manage a hotel booking, here are all the requirements that usually come up in the discussion. Here are all the endpoints that come up based on your requirements. Here are how we usually satisfy those requirements, things like that. So like I was trying to frame, basically, you give me a problem, I try to give you a frame, go back and forth, add another functionality, delete another functionality. We basically build all the functionality and you decide how you want to iterate on each functionality. If that makes sense.
Yeah, and I think like you're hitting a lot of good points there where like I feel that those are the primary reason why some of the AI generated code right now it's not making to production
Yeah.
because those contract you're describing are getting broken. Are there are security flaws being detected?
Yes.
It's recently with Mythos, and therefore it was rolled back by government. I'm curious, how do you see in with the contract first development, does it make easier to catch failures?
Because now that you're writing software in a way that it's structured, how do I put this? Like imagine you're building a house, and then because the way you source, I put a door there first. Until a certain point, I figure out, well, I need to put on, it's pretty likely to fall if you don't properly structure your column where the wall will be. So I put the column first, super secure, super low bearing, and I put a wall next to it. I know exactly it will work. So I take this analogy exactly to, contract first development is I tell you, if you don't build this endpoint, your app is not going to be able to fetch any new hotel. So you must build this endpoint. And so the way I think about it is because you have basically I am giving you the knowledge of how to build a software with the structure. So it's less easy for you to make a mistake. Like the same thinking. Like remember when we were working together, we were building platform is very similar. I give you so many things like when you create a data infrastructure resource, I put in all the security for you already. You don't need to know what happened. You just need to know when you provision this is super secure. So it's the same reasoning. Like basically I give you all the hardening, all the security, all the guardrail you could possibly need. When I have two endpoint booking at the same time, so the two endpoint will organically crash for no reason. So it's the thinking is like that.
Comparing your analogy to seatbelt in car, if you were designing agentic AI systems
Yeah.
from day one, what will that look in practice? How can we build agentic AI?
What is there to basically fend those off? So there are, depending on how you're using it, where you're using it, there's a lot of defense mechanisms involved. For example, we let the agent runs in a secured Kubernetes pod, so we don't have to worry. Yeah, you can delete this whole pod. Okay, then the pod is gone. Then we know the agent. More like okay, today I'm thinking of something malicious I want to implement. Oh, somebody download my agent. Oh, great. I'm going to look through all their data, things like that. That is horrible. So it's more for the people who is not sure, not as familiar about how these things work, and they download it and they're using it, that they are exposed to more security risk. But on the enterprise level, or like me personally, I will just say I'm a little hesitant. Like I tried it, I used it, it was fun, but not in the way that if you have a lot to lose. Like if you're in an enterprise environment, you have much more valuable information in your environment. If you delete something, your production system is actually gonna break. Then yes, you need to put a lot more guardrails around how you build agentic execution environment. That is for example, a dedicated pod, secure pod is like one of those examples. But there's so many other ways to catch this. Like you can scan your agent to see if there's any like underlying the model is using. Is it safe? You can do a vulnerability scan on those underlying models. For example, there's also auditing. Like we try to see every single thing that the agent is using. If the agent makes a wrong, a suspicious, execution code, then the audit will eventually immediately say that is a suspicious code. Why are you doing that? And we will be able to say, okay, this agent, maybe not working properly. So things like there's a lot of, in my opinion, security is one of the important aspects for a lot of business to feel comfortable to adapt. And then comes to the utility piece of it, which is like the correctness of it. Also a big problem. So that's why we talk about, evaluation, being able to benchmark, things like that. Like you, how do I put it? You will have to build a lot of these different utility around large language model in the years to come. And I think a lot of companies are start building that, but I think it's still a lot more. There's not, for example, how do you assert the agent is doing the exact right task? Is there any checks around the agent? Today, probably not. Even if you audit, that's just audit. You don't know if it's working properly. But yeah, there's a lot of framework you could build around this execution, just like how you used to write code, except the code right now could be somewhat of a generated code, and you still need, the checks around the execution to make sure it's doing exactly what you want.
I'm curious, how do you see things evolving for startup versus big enterprise company? A big enterprise company has more leverage around what security best practices they can do. At Blog, for example, we had like a lot of a whole security team which was driving security checkpoints for migrations when we were leading that. But for a startup, those are heavy processes to implement, and particularly in the era we are living in, the startups, it's a startup ecosystem where more and more startups are getting created every day. So what do you think about startup ecosystem? How do we build more trustable agentic AI flows?
Yeah, like the way. So why do you need trust as a business? Like, actually, you want people to, when people use your product, they don't have to worry. Oh, my data got hacked. Oh, my entire bank account is cleaned. Things like that. So how do you make that happen? I will be super honest. How you solve this problem usually is from two directions. One is the company itself, in order to earn business, they're gonna have to make their own product secure. Like you're not gonna go out and sell like a very dangerous thing. Like you come on my platform, I'm gonna delete all your stuff. Like if you sell this kind of product, even though your product might be able to make them $5 a day, but it's gonna delete all your emails from time to time. Like even though this product is a interesting product, but then nobody is probably gonna use it because people are not comfortable. So business have a goal to build a product that is nice, like that is benign, that is not harmful to the users. So that is one way that the business trying to build a product is going to basically make their software safe. So like how do companies do that? We do that all the time, right? When we build software, like we have a bunch of tests to make sure, You got to pass the vulnerability test. You got to pass the code scan, like static code scan. You got to have a design in place to make sure you cannot get access to users XYZ, things like that. You don't over permissioning to users' data. So there's one side of the push is from business trying to earn the customer's trust. I would say for a bigger company, especially smaller company trying to do business with bigger company, the push comes from, regulations, SOX, the security audit, things like that. That is why like an even smaller startup is trying to get those certification so then they can work with bigger business because the rigor of trust is much higher when you wanted to be part of the bigger company's supply chain, software supply chain. So if that is the case, that is again like a different set of requirement boxes. Remember, we're checking boxes that you need to check to make sure your software is able to do GDPR. Like those InfoSec certification programs is to help you, make sure, basically giving you a list of boxes to check. They are not easy, but to ensure your system meets certain criteria. I think those boxes will still be very, very valuable when you're building a product. And if your goal is essentially to sell to bigger company or to, have a higher rigor of your security standards, you should still like try to meet those boxes. But to put it like going into a little bit future, will those boxes, will the existing standard be enough to handle the agentic execution? I think there might actually be additional boxes that we need to create for the additional agentic execution. For example, how do you retain? If you do retain in your large language model, it's very common for us to retain some information and use that to retrain the next generation model to refine the behavior of the model, refine the improvement of the model. So it's very normal practice for us to retain. And if you remember when we were working together, we were like being so careful about if we are able to delete all the data a user has in the past, like that becomes so complicated because your model is not cheap to retrain. And now you have this additional problem where I use certain users' input to retrain. Whether that input consists of that user's data or not is hard to say. So I think we're actually having more problems on those type of, data security, data privacy, those type of problems. Another common example I can share is, I don't know if I think a lot of people, developer who's like vibe coding, they just, here is my API key. Can you tell me where to put? Happens all the time. They don't know. They don't know this is a problem. And then you don't even know, right? In my development environment, I put API key inside, an environment variable. My coding agent might be able to access it. How do you know that it's not going to take it and do something else with the API key? And you hear that horror story a lot. Like people don't know, people vibe coded API key in public, $20,000 in 2 days. You see that horror story all the time. So actually, I would actually think the standard, like on top of what we have today, like the SOX, the InfoSec audit, those audit on top of it, I think there will need to be like additional data control or additional layer of security checks, privacy checks on top of what we have today. Just because the flow that works today, there's very little boundary between what is the agent reading, what is my local data, if that makes sense.
Totally does. You summarized it beautifully around what agent believes versus what agent is doing. And we need to be really careful what API key access we are giving where, because agent can put it out in the world and can be charged $20,000. And so those are scary nightmares. To close this, I'll start by asking you some lightning round of questions, and whatever first thought comes to your mind, just answer it. One belief that AI coding agent you hold that most engineers would push back on.
I think it writes better code than I do, actually. I really think so. It might just be me incapable of writing good code, but I really think it writes beautiful code sometimes.
If This conversation made you think twice about how you are building with AI agent. That's the point. The infrastructure, the guardrails, the contracts. These aren't boring back-end details. They are what separates a cool DM from a production system